Okay, the next thing that we're going to be working on, we are going to further extend our skills of factoring expressions and solving equations, and we're going to do that through word problems, problem solving. Just like we might have had in the past, the sum of three consecutive integers, the third of the three integers is 2 more than the second, all kinds of things like that. We're now going to say, what if I told you that I had 3 consecutive integers, and I told you that their sum, that the sum of their squares is 50. Okay, again, 3 consecutive integers, x plus 1, and x plus 2 is always a good way to start. And I'm telling you that the sum of their squares, so what is that telling you? It's telling you x squared plus x plus 1 squared plus x plus 2 squared equals 50. Again, we're just translating words into symbols. It's telling you 3 consecutive integers. I have my algebraic representation of those 3 integers. And then I can say that their squares are x squared, x plus 1 squared, and x plus 2 squared. And now I'm taking the sum. Addition equals 50. Okay, this one is already as simple as it can get for right now. This one, let's make sure that we expand it out. X squared plus 1x plus another 1x plus 1. Let's do the same thing here. Expand it out. X squared plus 2x plus 2x plus 4 equals 50. Bring down that first x squared, bring down the plus sign, bring down this plus sign. Now let's indicate our like terms. X squared plus x squared plus x squared gives me 3x squared. 1x plus 1x plus 2x plus 2x gives me 6x. 1 plus 4 is 5. Okay, we've been doing a bunch of these types of problems. They should look pretty familiar. You should be thinking subtracting 50 from both sides, so that we can get one side equal to 0. Aha, that's the bell, but you're not going anywhere. Equals 0. 3x squared plus 6x minus 45 equals 0. We need to solve this. What are we looking for first? Always our first bet, is there anything common to all 3? And there is. They're all multiples of 3. Pull out that 3. The 6x becomes a 2x. The 45 becomes a 15. Now we have a pretty straightforward x squared plus 2x minus 15, which we know how to factor. If you need to write out the factors over here on the side, you can, but I think this one is pretty quick work for us. So negative 15. We can see the pair of numbers that I'm looking for is 3 and negative 5. And no. Negative 3 and positive 5. Always a good idea to write it out, because sometimes you flip the signs in your head. X minus 3 because of the negative 3. X plus 5 because of the positive 5. Now the final step. The 3 doesn't matter because 3 obviously doesn't equal 0. X minus 3 equals 0. So x equals 3, or x plus 5 equals 0, x equals negative 5. Now let's come back up here. Which could it be? Right, we've been saying or all along. Does that mean that x equals 3 or x equals negative 5? Are they both possibilities? Let's take a look at that. Very important. If x is 3, x plus 1 is 4, and x plus 2 is 5, what's 3 squared? 9. 4 squared equals 16. 5 squared equals 25. Add them up, you get 50. What if I had done the negative 5? Would I still get a correct answer? Negative 5. What's negative 5 plus 1 is negative 4. Negative 5 plus 2 is negative 3. What happens if I square each one? Now, I know some of you are thinking about this negative inside the parentheses. How do I know if the negative gets squared or not? Well, x is negative 5. You're doing x squared, x times x. Negative 5 times negative 5 will give us a positive 25. Negative 4 times negative 4 gives us a positive 16. Negative 3 times negative 3 gives us a positive 9. What's the sum? 50. They are both valid possible answers. Okay? We have our or, two possibilities. Positive numbers gives us a 50. These negative numbers, because when they square they become positive, also gives us 50. What would be a scenario where one of these was no longer possible? If I asked you positive. If I told you that I'm looking for 3 positive consecutive integers, well, now this negative is not an option. Okay, very important to look at the wording. If the problem specifies positive, I need to be sure that you're going to cross out that negative 5, because negative 5 is not positive, it's negative. Okay, so again, we look at the wording of the problem carefully. We started out in the blue by saying 3 consecutive integers, x, x plus 1, and x plus 2. And remember, in the initial problem, just the blue, I didn't specify if it was positive or negative. So you could just call it x. X could be whatever you want. X is unknown. There are no restrictions on x. The restrictions only come at the end. At the end, we look at our possibilities and say, I got to throw out that negative 5 because it doesn't meet the requirement. Just like we had cases where you were looking for even consecutive integers and your final answer was a negative, was an odd number. What does that mean? It meant no solution. We were looking for an even consecutive integers, but I only found odds, so it didn't work. Okay, let's take a look at another problem. What if I asked you, what if I told you I had 4 consecutive positive odd integers? Okay, very important to notice the wording. I've specified that they're consecutive, that they're positive, and that they're odd. Okay? So what are my variables? What am I going to start with? Always starting with an x. But since they're positive, since they're odd, what does that mean? They jump by 2. Okay, remember we did problems like that where we pointed out, we know that odd numbers jump by 2s. Even numbers also jump by 2s. So the fact that this says odd tells us that we need to jump by 2's. Now, have I specified positive anywhere in here? Nope. I have not specified anywhere that it's positive. Okay? So now, what if I want to do something similar where let's say I wanted to, let's say I was told sum of their squares was 164. Okay, so now we have our x squared. Go through that same process again. Side reminder, I'm going to keep reminding people of this until I'm sure that nobody is making this mistake. X plus 2 squared does not equal x squared plus 4. Very important. If I gave you 3 plus 2 squared, is that equal to 3 squared plus 2 squared? Well, 3 plus 2 is 5. 5 squared is 25. Is that equal to 9 plus 4? No, absolutely not. Okay, so just a side reminder that this is not a valid shortcut. This was x plus 2 squared, x plus 4 squared, x plus 6 squared, okay, so I have x squared plus 4x plus 4, right? Distribute, plus x squared plus 8x plus 16, plus x squared plus 12x okay, remember distributing, foiling in each place. Good. Now we're going to combine like terms. I have 4x squareds, and I have a 4x, an 8x, and a 12x. That's going to give me 24x. 2 marks there. 3 marks. 4 plus 16 is 20, plus 36 is 56. Okay, again, we're at a familiar point. We're at this point where we know what to do. We know to subtract 164 so I can get one side equal to 0. 4x squared plus 24x minus 108 equals 0. This looks familiar. We know how to solve this. We know how to solve something if it has a 4 in front of the x squared. But we also can see that we can pull out that 4 because they're all multiples of 4. Okay, now x squared plus 6x minus 7. I'm looking for a product of negative 27, a sum of 6, and that's going to get me negative 3 and 9. X minus 3, x plus 9 equals 0. So that tells me x minus 3 equals 0. Or x equals negative 9. We've got to stop and think. Are both of these valid contenders for an answer here? Come back to the wording of the problem. It says 4 consecutive positive. Got to cross out that negative. Can't have a negative number if the problem specifies that they must be positive. So now let's take our 3, 5, 7, and 9. Let's just double check. 3 squared equals 9. 5 squared equals 25. 7 squared equals 49. 9 squared equals 81. Let's add them up. 81 plus 49 is 130. Sorry, I'll write that a little differently. That's 130. These are 34. 130 plus 34 equals 164. Check. We did it correctly. Okay? That's it for now. I'm going to give you some time to work some problems, some practice problems on your own, looking out for different possible mistakes, possible errors that could come in, little annoying things, not reflecting a lack of understanding, but combining like terms. Sometimes people make mistakes there. A reminder, the value of making these little marks to show what the like terms are. Little mistakes that could come up are just little arithmetic mistakes here. But remember the jumps of 2. Remember eliminating answers that don't fit with the wording. And all of these problems allow you to check your own work like this to make sure you've done it correctly. Have a great day.